Hello everybody, and welcome to my presentation for Robotics 347, Robotic Navigation, University of Technology. This was going to be kind of long because there's three parts to it. So basically what I had to do is I had to test out the sensors for my robot. I've got three of them that we use. Well, one of them is packaged together, but for all intents and purposes, I've got three different experiments to do. The first one is an ultrasonic sensor. The second one is a gyroscope, and the third one is an accelerometer. We're going to start off with the ultrasonic sensor, and then we'll go to the gyroscope, and then we'll go to the accelerometer. So let's start. Okay, so for the ultrasonic sensor, I had to come up with a way to determine if that thing was working right. So my first impression to do this was to use the serial bus on the Arduino to print out the distances, which I can do and I do. But I had no way to test it on the robot because the robot, well, in order to put something on there like a display to determine whether or not it's sensing stuff, I would have to kind of I'd have to modify it, and I didn't want to do it because I didn't want to take a chance on ruining the robot at the time. But I found a way to do it. You had to think outside the box. Now, this robot unit has an RGB light on it. So I thought to myself, I could use this RGB light to determine distances. So what I did is I programmed this robot to sense if there's an obstacle in front of it. And if there's no obstacle in front of it between 12 inches or greater, that is either one foot or greater, there's going to be a green light that lights up on the car as it moves forward. Now, if the ultrasonic sensor senses an obstacle within 12 inches to 4 inches, the light is going to turn yellow to indicate caution, and the car is going to drop, or the robot's going to drop down to half speed. If the robot senses an obstacle 4 inches or less, the light's going to turn red and the robot is going to stop. So that's how we're going to determine this. Now, to get into the code, I used Adafruit's NeoPixel library because the RGB light on it is a WS2812, and when I looked up the data sheet, it's a NeoPixel. So we were able to get away with that, and it works good. What I really like about this RGB light is instead of having three anodes or three cathodes, with the opposite being the common, this basically runs off of one input. And there's code in it that will change the RGB. I think it's really neat how they did that. Okay, so we're using the Adafruit NeoPixel to change the color of the light. Okay, that is all of this stuff here. For the distance sensor, the ultrasonic distance sensor, I had to have a trigger and an echo pin because the way it works is it sends out a high-pitched noise and then it bounces back, and we take that, the result of that and multiply or divide it by a certain number, which is the speed of sound, and we can tell how close something is to us. And if we divide it by a certain number, we can get feet or we can get centimeters. I decided to do feet because I'm an American and we like feet. So there you go. With NeoPixels lights, you can run a strand of them. So I had to make a constant integer to tell the program that we're only using one RGB light. And that LED light is on pin 4. I have a duration and a distance. These integers help me to calculate the distance of an object with the sensor. This is how we initiate the Adafruit NeoPixel right here. The delay value, I don't use that too much. So I have a bunch of standbys here, or I have not standbys. I have a bunch of defines here that define different pins, and this is for your H bridge basically. So standby is going to add power to it. Pulse width modulation pins are going to determine the speed of the motor, and these pins here determine whether the motor is going to go forward and reverse. So I have declared a bunch of pin modes to the corresponding pins that control things and set them all to output except for the echo, which is an input. I start the serial monitor. In the main loop, I call pixel clear, which it's going to get rid of all the colors. Basically, it shuts the pixel light off. Then I turn the trigger pin on. I wait a second. I turn the trigger pin off. We have the duration, and we have a pulse in. We have the echo pin. We turn that on. We take the distance from that, which is the duration divided by 2. Okay, so the duration is the pulse in, and we divide that by 2. And then we divide that by 74, and we get feet. Okay. I print out the distance to the serial monitor. And then I basically have a for loop here, which is going to run through the lights. There's only one, but this is how NeoPixel does it. And I say if the distance is greater than 12 inches, the light's going to be green. And then we're going to print out to the serial bus forward go, which is basically the function that's going to make the car go forward. If the distance is greater than 12 and the distance is less than 12 inches and greater than 4 inches, we're going to get yellow light, and then it's going to print forward caution, and then we're going to go into the caution mode, and the car's going to drive forward at half speed. So if the distance is equal to or less than 4 inches, then the light turns red. We print out stop to the serial bus, and the robot stops. That's it. Forward go, forward caution, forward stop. Okay, so how we do this is we write to the pulse width modulation pins, tell how fast we want to go. We write to the input pins for the motors. If you want to go forward, it's high. If you want to go backwards, it's low. If you want to turn, you differentiate. Standby's high, so it's on. Same thing with forward caution. I said we drop the speed down, and then robot stop, we go to low. So that's that. I'm just going to jump right in now and show you the video for the car working. It does work on the serial monitor, but I don't have the car plugged into the serial monitor right now. It does work accurately, though. It is pretty accurate. So without further ado, we will jump right into the video, and then we will go into the next part, which is the gyroscope. Thank you, guys. Hey, everybody. Okay, for this experiment, I have my robot, and I have an obstacle, which is this ottoman right here. Now, I have on the floor, I have 2 spots marked off. One at 4 inches from the ottoman, one at 12 inches from the ottoman. And what's going to happen is this car's going to drive forward. And as long as we don't have anything in front of us that is either 12 inches or more, so a foot or more, the green light is going to be on the robot, and it's going to drive forward at normal speed. Once it reaches a 12-inch obstacle, an obstacle that is 12 inches away, it's going to go into caution mode. The light is going to turn yellow, and then we're going to proceed at half speed. Once the distance sensor figures out that the object in front of it is 4 inches or less, the light is going to turn red, and the robot will stop. So let's do this. Okay, so as you can see, the way I have it right now is it's going to run with the green light on, and here we go. Green light, green light, green light, and it reaches did you see that? When it reached the 12-inch mark, it slowed down and turned yellow, and then when it reaches the 4-inch mark, it stops and turns red. So that's how I'm able to determine the distance on this. We had to think outside of the box a little bit, and it works. Let's try it again. Turns yellow, turns red. Beautiful. Okay, thanks guys. Have a good one. Okay guys, welcome back to the second part here. This is the gyroscope. So the gyroscope is a little different. Basically we use I'm using a library that I like here. It's the MPU 6050 TOCKN.H. That's the header file. I really like this library. It's very simple to use. It works without a hitch. We use wire because we're using I2C bus for the accelerometer to get the information. I also use the Adafruit NeoPixels because just like the previous experiment, we're going to use the LED lights to determine if the car is moving or pivoting left or pivoting right. So if it's pivoting right, you'll get a green light. If it's pivoting left, you'll get a red light. And that is how we're going to tell if there's a deviation between zero. So what I mean by that is we're going to center this robot at 0 degrees on the z-axis. Then we're going to pivot it to the right and watch the robot turn back to the 0 position. And then we're going to pivot to the left and watch it turn back to the 0 position. So when it does that, the lights indicate what side of the axis we're doing. So if it's a positive axis, we move it to the left. If it's a negative axis, we move it to the right, and then it's got to correct itself. It works great. I can't believe how well it works. It's amazing how this works. So program is very simple. I define a bunch of pins here. These are all for the H bridge and the motors. I have an integer motor speed that's going to control the speed. So I found 60 on the pulse width modulation is just about right for this. If I drop it any lower, the car doesn't run as well, or the robot doesn't run as well. I have an integer called absolute and an integer called target. Target is the 0 point. That is where we want the car to go, or the robot to go. I keep calling it the car. I guess you could say it is. I'm old school, so I'm used to remote control cars. I don't call them robots. Sorry about that. Anyway, with the absolute integer, we're basically taking that and using that as the position that the car is in. So we say absolute equals target, or if absolute deviates from target, we're going to do something. Okay. So for the lights, we have LED 1 and number pixel. Those are constant integers. Pin 4 is where the light's at. Number of pixels, that's how many RGBs we got. This is how we call it, or we set it up. In the setup, I start up the serial monitor. We start up the I2C bus. We call the MPU 6050, which is the gyroscope accelerometer. And I calculate the offsets. Okay, so what this does is basically it zeroes it out. It zeroes out the gyroscope accelerometer unit to 0 wherever you put it. So you want to make sure it's still for a little bit. And then I call these pin modes, which are basically the pins that we're going to be used for outputs. So in the main loop, we set that light off. Absolute equals the gyro angle Z of the MPU 6050. That's how we get the position. Getting gyro angle Z, we're getting the position of the Z-axis for the gyroscope. And that's how it does that. So then we update the MPU 6050, and then we print out gyro Z, and then we print out the angle for it. Works great. Then we say, well, absolute, that's what this ABS means, absolute minus target. Okay, so what this is we're going to take that number and minus the target. Okay, and we're going to actually, I used 4 here, so we can go either 4 degrees to the left or 4 degrees to the right, and it'll stop, because otherwise what's going to happen here is when the robot tries to reassert itself to the zero position, it might toggle between left and right a few times. So it's going to be jerky for a few seconds before it settles back down to zero. You do lose a little bit of accuracy doing this, but not much. 4 degrees either side to me is not that much. And what this does is it stops it from doing that, so it goes right back to the position it's supposed to be in, and it doesn't jostle around. So basically, we say the lights are going to work here. If we go this way, it's going to turn green, and then we're going to turn the car back to the zero position. If it goes this way, it turns red, and then we're going to turn the car back to the position that it was supposed to be in. So that's how that works. And then we get the angle again. We update the MPU 6050 and get the angle again to see if it is within tolerance. If it's not, we do it again until it is back to zero. Once it's back to zero, it jumps out of this while loop. I have a while loop here that's all done in a while loop, and then it stops the robot. So that's how that works. Pretty simple, guys. So I'm going to jump right into the video because it's kind of long, but take my word for it. You can run this code yourself. It is accurate. It works great. On to the video. Thank you very much, guys. Hey everybody. For this experiment, we had to test out a gyroscope along the z-axis. So the z-axis, if you rotate around the z-axis, you're going to get yaw. You're either going to be pitched to the left or to the right. So for this experiment, what we had to do is find position 0, mark it off. I have it right here taped off. This is position 0. And if I move the car left or right, or, pivot it left or right, it should return to that axis automatically. Furthermore, to demonstrate that the gyroscope is working and picking up whether it is going on, going to the left or going to the right, if the car has to turn back to the left to get to position 0, a red light will appear. If it has to turn right to get to position 0, a green light will appear. So let's go ahead and start this. So that had to go right, so it turned green. That it turned red because it had to go to the left. So let's, as you can see, it's pretty accurate. I mean, it keeps returning back to the original position. It's sliding around a little bit, but that doesn't mean anything. It is going back to the 0 position every time. And furthermore, it is picking up whether it is turning left or turning right, which is pretty cool. I had to think outside the box for this one. So that is my presentation, or my assignment, my experiment, I should say. Thanks, guys. Have a good one. Okay, guys, so on to the third part, the accelerometer. The accelerometer is actually part of the gyroscopic unit. So I need to take that out, first of all, because we're not using a gyroscope. I just got done with this code. So anyway, we use the same library. We use the I2C library, the wire library. We're using the NeoPixel stuff. Everything is set up the same previously, except for one thing. So instead of going on the X or on the Z axis of the gyro, we're getting the X axis on the gyro. Now I had to be careful because there's the X axis and then there's the X axis angle, which is basically, for the X axis is going to be your pitch, and then on the Y axis would be roll, and then Z would be yaw. So I had to do it this way. So we set the absolute. As you remember, absolute is going to get the position of whatever we're looking at, and that is the position of the X position of the gyro. So and then we set we print out the acceleration for this. So I don't know why they're using gyro X. They do have an acceleration for it too, but this is the axis that we use to determine the speed for some reason. I checked it out. It works good. You will see it in the demo. Okay, so anyway, we start printing out the numbers for it. And while actually equals target. This time I use 0. There is no margin here. We don't give any kind of leeway. The last one I used 4 degrees on either side. This is absolute dead 0. So what happens is, what's going to happen with this is the car is going to, or the robot's going to boot up, okay? And it's just going to sit there. And it's going to wait for something to happen. It's going to wait to feel either it's going to go either a forward nudge or a reverse nudge. So if it goes forward, it's going to start driving forward. Green light is going to turn on. Then it's going to randomly go from forward to backwards. When it goes backwards, when it senses the accelerometer going on the z-axis in reverse, a red light's going to show up. If the car or the robot is going forward and the accelerometer picks that up, a green light is going to go on, and that is how we're going to determine that this is working right. So I'm just going to be honest with you, it works pretty good. So what we do here is we just basically the same way. We just say if the absolute is less than the target, we're going to move forward. If it's greater than the target, we're going to move in reverse. If it's, well, I don't really stop. I don't use stop in this one because you'll see it just keeps in motion and it's going to go forward and backward, and it'll show you what's up. Okay, so anyway, that is that. Here's the last part of the video of the car moving back and forth. Guys, I spent a lot of time on this and I still got to do my report, so I'm going to cut this short as possible. Anyway, thank you very much, guys. Have a wonderful day. Guys, okay, for this experiment, we are going to experiment with the accelerometer forward and reverse. So this car is going to drive sporadically forward and reverse. And to tell that the accelerometer is picking up the direction it's supposed to go, if it is going forward, the green light will turn on. If it is going backwards, the red light will turn on. Let's give it a go. All right, we're going to have to let it warm up for a second here. We'll let it warm up. And then we have to give it a nudge. So it knows it's going forward. See the green light's on? Okay, now it knows it's going backwards. Forward, backward, forward, backward. See? And each time the light changes when it senses a direction change. So that's how it works, and it's working pretty good because it is detecting if it's going forward or backward. So let's see if we can get it to go forward. Here we go. That's it. Pretty cool, huh? All right, guys, thanks a lot.